Okay, I'm going to talk on behalf of my colleagues from IH Cantabria. Here you have a list of them, but there are more than those because we use a lot of the Copernicus marine data. We are a research institute. We are located at the north of Spain in Santander. This is our main facility, the Coastal and Ocean Basin. It's a unique scientific and technical infrastructure. We are around 140 researchers, and our main aim is to become a leading international research center in the field of water. Right, you already know this, but this I think is important. The ocean, the coastal zone is very, very dynamic, and that's why the Copernicus services, the Marine Copernicus services providing a lot of data, and you are providing a lot of very interesting and valuable products. We also have seen these days that we have other data providers, so the Climate Change Service, for example, InputNet or NOAA. And here we have the intermediate users. So we, at Cantabria, we are an intermediate user, and what we try to do is to try to transform this data into tailored information on products, to be able to provide knowledge to the end users that can be government, citizen, or companies. I have to say that we are also a Copernicus Academy member, so we try to foster the Copernicus program in all our activities. So what the intermediate users do, you have seen some user uptake projects before, but we basically, what we do is to knock on end user doors. And by saying this, I mean that there are plenty of potential end users' doors closed, and we have to open it to be able to provide tailored information products to them. I want to show you some downstream services that we are developing in our institute, so you can have the idea of our perspective about the future of the Copernicus Marine Service. I'm going to talk about flooding, oil spill, HNS, Sebastian yesterday talked about this, drowning, risk of drowning. We are providing information also for the Spanish Navy, sailing or nautical sports, port management, aquaculture, and marine renewable energies. So I don't have 1 hour to talk about all of this, so I will try to briefly introduce one of, mainly one project for these topics. And if you want more information, we can talk in the coffee time, okay? In terms of oil spill, we have been working together. This is important. We are working together with CEPSA, an oil and gas company, to build this system. We started to build this system in 2012. So at that time, we started to use MyOcean data, and then the Copernicus products start to come, so we have to evolve the system and integrate it. And also the Port Authority in Spain, the National Port Authority, Puertos del Estado, they also started to provide under an open data approach downscalings at the harbors. So we have to thank them because this is very good for us because we can focus our effort in trying to build modules for CEPSA. So we don't have to focus on trying to do all the numerical thing. I have to mention that in this system was used in a real situation in 2016. They had an oil spill, it was dark, so they used the tool to be able to see the trajectory and collect almost all the oil spill that they had. So this is a successful successful case that we had, and we are happy for that. In terms of HNS, I'm not going to introduce it because it was introduced yesterday. We have this project. In this project, we are starting this year, so we have 3 years ahead to work with CEPSA to try to work with, in terms of HNS spills decision support. Flooding. I brought this example here. This is a system that we built almost 7 years ago for the Omani government. It's an old storm surge forecasting system. And I have to say that we had to use at that time data from other agencies, in this case NOAA, and we also use data from the ESA initiative, Gulf Wave, to be able to validate the data. And this is a classic example that we were intermediate users even before the Copernicus program was there. And now we can use European data sets, and we don't have to ask for data to other external agencies. And this is important for us. Here you see an example of a tropical cyclone in 2015. We provided the forecast for them, and at the end, this is the Chapala tropical cyclone. It hit Yemen at the end and causes the seven deaths. Okay, another kind of product is a high-resolution coastal flooding that we are using for the Canary Island. They have a big problem there in that road. So you can see there in that storm in 2018. So we are providing a forecast for them to be able to take the good decisions. Sailing, we are also building some products for sailing. This is a product for, you see there all the marinas in the coast of Spain. We are also building products in a high resolution scale. This is the Bay of Santander. There we have a lot of championships of sailing, so the municipality asked us to provide currents in real time and forecasting for the competition. So these are two examples. In Aberdeen, we are providing this service, the early alert system for harbor construction management. It is provided for the company Dragados. So we provide everyday reports on what is the forecast and things like this for them so they can operate correctly. With the Spanish Navy, we are starting this project right now. We are going to build a forecast system for amphibious landing and navigation. So we will use the data of Copernicus to do that. We are doing some previous analysis right now. Droning, this is a user uptake project. This started last week, sorry. And the main aim is trying to build a kind of electronic flag. So we are working with the Brazilian Lifeguard Association. They have a lot of information about the drowning events in the last 10 years or more. So we are going to use that information, the reanalysis data from Copernicus Marine, and we are going to build an artificial neural network to be able to provide a forecast and provide these electronic flags. So at the end user can know the risk at any beach, even if it's an unattended beach. Okay. In terms of marine renewable energies, what we are doing in this project, we are almost finishing this project. We are providing this kind of testing for engineers that are building devices for marine renewable energies. So what we provide to them is the capacity to test their devices at overlap, also at the real site, at the BMEP test site, and also in a virtual decision support system in which we are using the Copernicus Marine data. In terms of aquaculture, we have another user uptake project in which we are working. This is a global project, but we think that we need to talk and engage with the end users. So we are building this local forecasting system to be able to know really the needs and the indicators that we have to use. So we are building this system just to learn from them which are the real needs, and then take that information to include it in the final global application, which is this one. It's a marine spatial planning platform. It was presented last week in Vigo in an international forum that organized IOC UNESCO about marine spatial planning, so we collect a lot of feedback from them. We are trying to analyze aquaculture and marine renewable energy suitabilities to try to identify co-location opportunities in this user uptake project. We are also building this, we call it Blue Time Machine. We want to provide to the user the ability to go to the past and use the reanalysis data from Copernicus Marine, go to the present, see what the Copernicus Marine provides, short-term forecast, and also including the climate change. In here, with this idea, we applied for the EU Datathon, and we are very happy because we are among the finalists in the track of tackling climate change. So we will have to present our final application the 13th of June. Unfortunately, I will not be there because I will be in my honeymoon, but otherwise otherwise my wife will kill me. So, but yeah, we are very happy. And this is mainly the concept of the blue time machine. We can go to the past, we can take information from the boards, radar, all the information that you guys are building. I mean, it's amazing in just 5 years what you have achieved. And for us, it's like a present because we were in 6 years ago, we were looking for data all around the world. We looked for NOAA data, and now we can go to the Copernicus Mine Service, to the Climate Service, and try to build this kind of blue time machine. We could call it also white time machine and green time machine as well. So, but this is the concept from the intermediate users. We see that mainly we work in the day-to-day operational activities and we build tailored products for that. I think there is a lot of potential with this information, but we think that there is a lot of potential as well in this strategic planning. So with information from the past, and also information for the future, for the climate scenarios, the seasonal forecasting, we think that we can answer a lot of directives, European Marine directives with this information. In terms of user needs, the day-to-day operational activities need, you have commented in previous presentations. We need short-term with forecasts, river discharges forecast, a 10-day or 15-day wave forecast. And also for the strategic planning, we need more information about reanalysis in terms of waves. You said that you are working on that. Seasonal forecast and climate scenarios. I think it's what we need right now, but of course, at the end, this will evolve. And if I have to say something about a 10 years perspective, this is very complicated, but we could say that we would like to have operational bathymetry. We think that the potential users are at the coastal zone, most of them. So with an operational bathymetry from remote sensing, we could take that bathymeter and integrate it in our numerical modelings to be able to build a lot of products in a very local and high resolution scale. I think that would be very, very useful. In the other way, we have to integrate also the human activities. I mean, when we build downstream services, the humans are there, we are there, okay. And it's important to know where the people are and what they do at the coastal zone. The final thoughts, well, I brought this picture as well about WCAO. I'm sorry, I have to say bad things, but also good things. If we start with bad things, we have tested and it is a not mature version today, so we hope in October to test the final version. It doesn't have Windows operating systems and a lot of lack of data sets. It's fine, I think it's evolving a lot. So, but the good thing is that it's a cloud platform, so we have scalability, we have infrastructure as a service, and what we love is that it is a lot of fast access to the data, and also the harmonized data access is great. So as a final conclusion, I have to say that intermediate users will keep knocking on new end user doors to be able to build new and innovative applications. Thank you very much.